Thermal process furnace. The following discussion is about high temperature furnaces used in integrated circuit fabrication. Thermal processing. Silicon wafers go through thermal processing in high temperature furnaces and using rapid thermal processing RTP tools many times during the integrated circuit processing flow. The following discussion is about high temperature furnaces used in integrated circuit fabrication. We shall talk about rapid thermal processing in some other future discussion. Figure in next slide shows the integrated circuit fabrication process flow. Here integrated circuit fabrication flow chart is shown. The position of thermal process is shown here. Thermal process furnace, diffusion furnace, furnace and thermal process furnace are the names of the same equipment. Diffusion furnace. Thermal processes occur in a high temperature furnace called a diffusion furnace. There are two kinds of furnaces, horizontal and vertical, determined by the way the quartz tubes and heating elements are placed in the system. Typical requirements for a furnace include uniformity, accurate temperature control, low particulate contamination, high productivity, high reliability, and low cost. A furnace consists of 5 basic components: a control system, process tube, gas delivery system, exhaust system, and loading system. Sometimes a vacuum system is also required. The furnace used for low pressure CVD processing also requires a vacuum system. Request: it is hoped that this session is going to be useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। यह लेक्चर हिंदी में भी उपलब्ध है। This diagram shows schematics of horizontal furnace. Here we can see the quartz tube, wafers inside the quartz tube, heaters, the gas flow, and the temperature versus distance curve. In this slide we can see the schematics of vertical furnaces. So here we can see the process chamber, heaters, the wafers in form of a tower. A vertical furnace has many advantages over a horizontal furnace, such as lower particle contamination, the ability to handle a large number of heavy wafers, better uniformity, lower maintenance cost, and a smaller footprint. It is very important for a processing tool to have a small footprint, since high-grade clean room space is very expensive in advanced fabs. Also, because wafers are placed in vertical stacks, large particles fall only onto the top wafer and do not reach the wafers underneath. Vertical furnaces are more commonly used in advanced semiconductor fabs. Thermal process furnace. Most of the parts in a thermal process furnace, such as the wafer board, paddle, and wafer tower, are made of fused quartz. Quartz is a single crystal silicon dioxide, which is a very stable material even at high temperatures. Its drawbacks are fragility and metallic impurities. Because quartz is not a sodium barrier, a trace amount of sodium can always penetrate the tube and cause damage to devices on the wafer. When the temperature is higher than 1200 degrees centigrade, small flakes can occur and cause particle contamination. Silicon carbide is another material used for high temperature furnaces. Compared with quartz, silicon carbide has a higher thermal stability and is a better mobile ion barrier. The disadvantages of silicon carbide are that it is heavier and more expensive. As device dimensions are further reduced, more silicon carbide parts will be used in furnaces to meet processing requirements. Control system of a furnace. The controller consists of a computer connected to several microcontrollers. Each microcontroller connects to another system control interface board, which controls processing sequences such as wafer loading and unloading, processing times for each step, processing temperatures, and temperature ramp rates, processing gas flow rates, exhaust, etc. It also collects and analyzes processing data, programs the processing sequence, and tracks the lot numbers. Figure in next slide shows a block diagram of a furnace control system. This slide shows block diagram of the control system of a furnace. Here we can see that the computer is connected to various microcontrollers, and each microcontroller in turn is connected to process tube interface board, exhaust interface board, gas panel interface board, loading station interface board, and vacuum system interface board. Gas delivery system. The gas delivery system handles processing gases and delivers them to the processing tube as required. A gas panel consists of regulators, valves, mass flow controllers, and filters. It distributes processing and purge gases to the processing tube as needed. Processing gases are usually stored in high pressure bottles in a remote gas cabinet. Processing gases are throttled to a lower pressure and given to the gas panel. Regulators and valves monitor the processing gas pressure and control pressure. Gas flow rate is precisely controlled by the mass flow controller, which controls the rate by adjusting an internal control valve so that the measured flow rate equals the set value. Filters in the gas panel help minimize particulate contamination by preventing particles from flowing into the processing tube with the gases. Figure in next slide shows a schematic of a gas delivery system. A schematic of the gas delivery system. Loading system. The loading station is used for wafer loading, unloading, and temporary storage. It loads wafer from cassettes into quartz boards which sit on a quartz paddle. Then the paddle is gently pushed into the processing tube by a loading mechanism which is controlled by the microcontroller. After thermal processing, the paddle is gradually pulled out of the processing tube. Several paddle types have been used in the loading systems of the horizontal furnaces. Paddles with wheels are no longer used due to the particle generation caused by direct contact between the paddle and quartz tube. Soft landing paddles will gradually land on the quartz tube after the paddle is pushed into the desired position inside the processing tube were developed next. Due to direct contact between the paddle and quartz tube, soft landing paddles caused particulate contamination from friction between the paddle and tube wall during paddle landing and raising. To avoid this direct contact, suspended or cantilevered paddles are currently used in most systems. They allow the paddle to move in and out of the processing tube without any direct contact with the quartz surface, minimizing particle contamination. However, wafer loading can affect the pedal's suspension. For a vertical furnace, wafers are loaded from the cassette into the tower by a robot. Then a lift mechanism controlled by the microcontroller raises the tower into the processing chamber, or chamber elevator lowers the chamber until the entire tower is inside the chamber. This eliminates contact between the wafer holder and the quartz chamber wall, and there is no suspension problem for the wafer holder. Exhaust system. Process byproducts and unused source gases are removed from the processing tube or chamber by an exhaust system. Exhaust gas is evacuated from the processing tube symmetrically, and purge gas is drawn in from the exhaust manifold to prevent backstreaming of the exhaust gas. For furnace processes involving pyrophoric or flammable gases such as silane and hydrogen, an additional chamber called a burnt box is required. In the burnt box, exhaust gases pass through a controlled combusting process in the presence of oxygen and are reduced to less harmful, less reactive oxide compounds. Filters are used to remove particles generated in the burning processes, such as silicon dioxide after burning silane. A scrubber with water or an aqueous solution absorbs most of the toxic and corrosive gases before the exhaust gas is vented to the atmosphere. Processing tube. Wafers undergo a high temperature procedure in the processing tube, which consists of a quartz tube, chamber body, and several heaters. Thermocouples touch the chamber wall and monitor chamber temperature. Each heater is independently supplied by a high current power source. The power of each heater is controlled by feedback from the thermocouple data through the interface board and microcontroller, and becomes stable when the setting temperature is reached. Temperature is flat zone at the center of the tube is precisely controlled within 0.5 degrees centigrade at 1000 degrees centigrade. Figure in next slide shows schematics of horizontal and vertical furnaces. In a horizontal furnace, wafers are placed on quartz boards which sit on a pedal made of silicon carbide. The pedal with wafer boards is then slowly pushed into the quartz tube, where it places the wafers in the flat zone of the furnace for thermal processing. After processing, the wafers must be pulled out very slowly to avoid warping caused by the overwhelming thermal stress of sudden temperature change. In a vertical furnace, wafers are loaded into a wafer tower made of quartz or silicon carbide. The wafers are placed in the tower face up. Then the tower is slowly raised into the quartz tube to heat. Afterward, the tower is lowered slowly to avoid wafer warping. Request: it is hoped that this session was useful to you. Please press like button. प्लीज़ सब्सक्राइब दिस चैनल. यह लेक्चर हिंदी में भी उपलब्ध है. This lecture is dedicated to the loving memory of my late elder brother Shri Surendra Kumar Chadha.